On the ideal logic, if we have a problem with the gas valve, it can give us an L2 or an F2 fault code. We're going to go through some functional checks we can do on the gas valve. The first one, I'm going to connect my manometer to the test point on the gas cock underneath the boiler. We're always going to do the test at that point and never on the actual gas valve itself. So with my gauge connected now, I can see the standing pressure, which anything up to 30 millibar for your standing pressure is okay. So we've got 22.6, and then I'm going to put a demand on the boiler. As I put that demand on the boiler, I'm expecting to see a slight drop in pressure from the 22.6 that I've got there. It's going to drop down slightly. If I see that drop in pressure, that's indicating that the gas valve's opening up. If I don't see any drop in pressure, then I'm suspecting that there's an issue with that gas valve opening up. So there's a couple of checks we can do to see why it's not opening. Okay, so let's imagine the gas valve's not opening up and we've done that little blip test and we're not seeing any drop in pressure. The first test I'm going to do is, with my multimeter, I'm going to take a resistance check. So I'm going to turn power off to the boiler. And I'm going to put the multimeter onto resistance. The reading that I'm looking for is around 114.5 ohms, but that can be slightly higher, slightly lower, depending on temperature and a few other things. So as long as I'm not getting OL on the screen, I'm getting somewhere close to that 114.5 ohms, then I'll be happy with that. So let's see what we've got. So 2 outer connections on connection X3 on the PCB, and the way the connections go, we've got X1 on the left, X2, X3, X4, 5, 6, 7, 8, 9, and so on. So X3 is our gas valve. So if I go across there, just put the multimeter back on, go across there, and we can see I've got about 135 ohms there. So that would be okay, I'd be happy with that. If I was getting OL like that, that would indicate that I've either got a break in the harness from the PCB to the gas valve, or I've got an issue with my gas valve coil itself. Either of those faults and the gas valve's not going to open up. The next test I'm going to do is to see if I've got power coming from the board feeding the gas valve. So for this test, I'm going to put the multimeter onto volts DC, because this is a 24 volt DC gas valve. It tells us on the front of the gas valve that it's 24 volts DC, and also a good indicator is that we've got a blue tab there. So that blue tab is telling us it's a 24 volt gas valve. On some of our previous versions of the logic, there was a black tab, and that black tab is a 240 volt AC gas valve. So for this one, we're looking for 24 volts DC. So the multimeter's all set. I'm going to turn the power back on, and I'm going to put a demand on. And then I'm going across those same 2 connections again. And then as the boiler fires now, I should see 24 volts appear on my multimeter. So that's telling me that the PCB is sending out the correct voltage. I've already checked my harness, so I know that's good. So I know that I'm getting that 24 volts DC at my gas valve where I need it. If I was getting nothing from the PCB, then I'd be suspecting that there's a fault with the PCB, because I know my harness is good. If we're getting that correct voltage and all my other checks that we've just done are all good, we've got to suspect a faulty gas valve. So in that case, we'd be replacing the gas valve. If you like this video and you want to see more of this kind of content, leave us a comment and we'll try and make some more for you.